Here is some additional material that was not included in this session.
From the primordial cloud of gas and cosmic dust, gravity forged the stars. Gravity connects star systems together in vast galaxies and steers them on their journey through unbounded space. The relentless flow of time has driven the evolution of the universe and created extraordinary wonders. Some galaxies form so close together that they're locked in a gravitational embrace. What a magnificent sight it would be. As it evolves, the universe passes through distinct eras. Vast ages whose beginnings and endings are marked by unique milestones. The births and deaths of its wonders.
We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware.
Gravity is the great creator, the constructor of worlds. But gravity is also the destroyer, because it's relentless. When a star around 15 times the mass of our Sun collapses, all the matter in its core is crushed into an infinite void of blackness known as a stellar mass black hole. The immense gravitational pull of these monsters can rip a star apart. They tear matter from its surface and drag it into orbit. This superheated matter spins around the mouth of the black hole, and great jets of radiation fire from the core. Although these jets can be seen across the cosmos, the core itself remains a mystery. Not even light can escape. so their interior is forever hidden from us. Throughout a star's life, there is a constant battle between energy pushing out and gravity pushing in. When it runs out of fuel, the star collapses and then explodes with the brightness of 1 billion suns. As the star is torn apart, it will fire out into space all the elements that it created in its life and death. These are new stars forming from the elements blown out by supernova explosions. New stars being born from the remains of dead ones. And it's from this universal process of death and rebirth that we emerged. Because it was in a nebula just like this, 5 billion years ago, that our sun was formed. Clouds of hydrogen collapse further and further under the force of gravity, and the life cycle of a new star has begun. A star was born that would come to be known as the Sun. Around it, a network of planets formed. Among them was the Earth. Debris left over from the formation of the solar system collides with the Earth. Earth began life as a molten hell.
The early continents were still forming. The land was dominated by volcanoes, hostile and lifeless. But deep in the oceans, life had begun. The latest theory is that chemicals spewing from underwater volcanic vents solidified and created the conditions needed for the first cells to form. For some 3 billion years, simple microscopic organisms were the most advanced form of life on the planet. Cyanobacteria and other oxygen-producing microbes began to bloom. These flourished in colonies of plant-like microbes that pumped out enormous volumes of oxygen. And it was this increase in oxygen that was the key to the rise of the animal kingdom.
Organisms started using oxygen to respire, yielding a lot more energy, which allowed the development of more complex life.
Just before complex life appeared, the world was in the grip of the biggest ice age in its entire history. And then suddenly, advanced organisms appeared.
In 400 BCE, Democritus suggested that all matter was made up of atoms. In 1869, Mendeleev published his periodic table of the elements, or atoms, predicting the discovery of missing elements. In 1911, Ernest Rutherford proposed that atoms comprise a positive charge surrounded by negatively charged electrons. A couple of years later, Niels Bohr proposed his orbital model of an atom. This was later replaced by a quantum mechanical model through the work of Max Planck, Schrödinger, and others, in which electrons are waves whose position and energy are uncertain. Einstein's theory of general relativity assumes that space is smooth and continuous like a sheet, whereas quantum theory insists that the world and everything in it is grainy at the smallest scales, parcels into discrete lumps. Quantum principles are used in MRI imaging, atomic clocks, GPS, lasers, computers, and smartphones. Quantum theory works. Using a scanning tunneling microscope, invented by Binnig and Rohrer in 1981, we can now see individual atoms: gold, silicon, and carbon. In this photo, they form a nanotube. Since then, a whole slew of subatomic particles have been discovered, right up until the Higgs boson in 2012, using the Large Hadron Collider at CERN in Switzerland.
The Large Hadron Collider, or LHC. Inside this pipe, two beams of protons are sent hurtling around a nearly 17-mile loop before being smashed together to create subatomic particles.
Einstein's theory of relativity works on the large scale. Quantum mechanics works on the small scale. Scientists are working on creating a unified theory that works on both the small and large scale. In the meantime, we should be especially skeptical of attempts to explain large-scale events using quantum theory. For example, telepathic thoughts and other pseudoscientific claims. Many scientific discoveries involve light. A rainbow shows that sunlight contains different colours. In 1845, Faraday showed that magnetism affects light. Here he is, holding a piece of glass used in his experiment. In 1860, Maxwell inferred that light is an electromagnetic wave, and a small part of a much wider electromagnetic spectrum. Each part of the electromagnetic spectrum corresponds to a wave frequency. The higher the frequency, the greater the energy. All electromagnetic waves travel at the speed of light. We now heavily rely on devices that use electromagnetic waves, from health to communication. They have also enabled scientists to make further discoveries. When a substance is hot enough, it emits a unique light pattern. These are the light patterns of some elements detected by an instrument called a spectroscope. Astronomical spectroscopes are used to identify the composition of stars. They can also detect how fast space objects are moving. In 1964, Wilson and Penzias stumbled on background microwave radiation using the Horn antenna at Bell Laboratories. This radiation is everywhere and is the signature left by the Big Bang. In 1970, Vera Rubin used spiral galaxies to show that space contains invisible dark matter. The universe is full of invisible dark matter and dark energy. In fact, all of the stars and galaxies comprise only 0.7% of the total energy and matter in the universe. One of the mysteries yet to be explained. The first living cells were seen through a primitive microscope by van Leeuwenhoek in 1676. They included bacteria and blood cells. The average human is made of around 30 million cells. Viruses are much smaller than bacteria and require an electron microscope to be seen. Viruses are in the grey zone between the living and the non-living. They are like seeds, only coming to life when they invade a living cell. Molecules are atoms bound together. In 1783, Antoine Lavoisier, sometimes referred to as the father of chemistry, demonstrated that water is a molecule comprising two hydrogen atoms bonded with a single oxygen atom, H2O. Molecules can be joined together to create larger molecules. Hemoglobin is a protein molecule comprising 10,000 atoms of hydrogen, carbon, nitrogen, sulfur, oxygen, and iron. Every second, our bodies create 400 million of these molecules. Here is a video showing how DNA controls our bodies.
The human body is made up of different tissues, each with a specialist function. Let's zoom into the liver. Tissues are made up of cells specialised to perform different functions. Let's look inside this liver cell. Within each cell are specialised structures and compartments called organelles. The genome is found within an organelle called the nucleus. The genome is packaged into structures called chromosomes. There are 23 pairs of chromosomes, including 2 chromosomes that determine your sex. Women have 2 X chromosomes, men 1 X chromosome and 1 Y chromosome. Each chromosome is a length of DNA coiled up tightly to create structures called chromatin loops. When we look closer at these loops, we can see the DNA is wrapped around proteins known as histones to form structures called nucleosomes. DNA itself is a double helix, like a twisted ladder. It is made up of 4 letters or bases called adenine, cytosine, guanine and thymine, A, C, G and T. A always pairs with T and C always pairs with G. The order or sequence of these letters of DNA carry the instructions for how a cell behaves and functions. Specific sections of the DNA, called genes, carry the instructions for producing molecules. The human genome contains about 23,000 genes. You can think of the genome as an encyclopedia and the chromosomes as the books that make up the set. If you were to print out all 3 billion letters of the human genome, you would make 120 books.
We are indebted to the curiosity, skepticism, and determination of great scientists who challenged the status quo and expanded our understanding of the universe. How many of them do you recognize?